Today we are discussing bearing capacity of soil. So while considering the bearing capacity of soil, we must know about the foundation, that what foundation is. So foundation is a structure or a substructure, we can say, which bears the load of the whole building and transmits it to the soil, the underlying soil of it. This is a shape of its general foundation. So this is called width of the foundation, and this is called the depth of the foundation. It is denoted as capital DF, and hence this is ground surface. This is depth of the foundation and this is width of the foundations. So the father of the soil engineering, Carl Tajagi, gave an equation that the ratio of depth of foundation to the width of foundation, if it is less than equal to 1, then the foundation is termed as shallow foundation, and if it is not so, means depth of a foundation divided by width of the foundation is greater than 1, then it is termed as deep foundation. Okay, so these are the two types of the foundations. Now what bearing capacity is? Bearing capacity means the capacity of soil, underlying soil, to hold the load of the whole building without getting failure. So soil fails in shear. So different kinds of bearing capacity we will consider over here. So first of all, there are 5 types of bearing capacity, we can say. So first of all, there is gross bearing capacity. The first is ultimate bearing capacity. Ultimate bearing capacity of soil. So what is ultimate bearing capacity of the soil? It is the ultimate bearing capacity is the gross pressure at the base of the foundation at which the soil fails in shear. It is denoted as Q, when, or we can say the pressure borne by soil at which soil fails in shear. So what is that pressure? If we can say this is our foundation and this is width of the foundation, and P pressure is being exerted over this underlying soil, then load upon area means the whole area of this portion. If this is also B, because we are considering it as a square footing, then P upon area, yani B square, it will be the pressure. So QU is equals to P upon B square, where B is the width of the foundation, width of the square footing, you can say. Okay, the second is net ultimate bearing capacity. So it is denoted by Q and U. It is the net increase in the pressure at the base of the foundation that causes shear failure of the soil, and it is equal to the gross pressure minus overburden pressure. Gross pressure is this is also termed as gross pressure ultimate bearing capacity. So at Q and U, if we are considering gross pressure exerted by this sort of foundation, then pressure at this point due to the self weight of the soil, that is gamma into depth of foundation, gamma into H. What is gamma into H? This is pressure, as we have discussed in the previous lectures. That is means this pressure is diminished from the gross pressure, and we will get net ultimate bearing capacity, where QU is the ultimate bearing capacity, we can say gross, and gamma is unit weight of the foundation soil, and df is the depth of the foundation. This pressure we can say, this pressure was here, this soil was bearing this pressure before the construction of this structure. You can say the soil was bearing this pressure before the construction of this soil, but we are considering the bearing capacity of soil under the load we are applying to the soil after constructing a superstructure. So gamma df can be diminished whenever we are considering the net ultimate bearing capacity. Now the third is net safe bearing capacity. Net safe bearing capacity, whenever you see the name safe, then a term like factor of safety must be in your mind. Okay, so what is factor of safety? Factor of safety, if we are designing a structure like you have seen in RCC and steel, that factor of safety is 1.5 for RCC and 1.15 for steel, because we are designing or we are considering the quality or quantity of a material 1.5 times whatever we require, because we want the good quality of the product what we are constructing. So net safe bearing capacity is QNS, it is equals to QNU divided by factor of safety F, where F is factor of safety and generally it is taken as F is equals to 3.0 for general soil. Okay, these are three bearing capacities. Hence the fourth one is gross safe bearing capacity. It is denoted as QS. So what is this gross safe bearing capacity? It means it is the maximum gross pressure which the soil can carry safely without shear failure. It is equal to the net safe bearing capacity and the addition of, when gamma df is summed up, QS is equals to QNS net safe bearing capacity plus gamma df. What was QU? QU was QU in itself, and what was QNU? QNU was QU minus gamma df. If we divide it by factor of safety, that is QNS was QNU upon factor of safety. So QNU upon factor of safety plus gamma df. Okay, this is QS, gross safe bearing capacity. This formula must be remembered by everyone so that we can solve the problems whatever will be listed in our question. So the next is, we can say QS is equals to, some authors decided that QU divided by F. We can say QNU divided by F plus gamma df divided by F. It doesn't make difference. So the fifth one is net safe settlement pressure. So the maximum allowable settlement is considered at 25 to 40 mm for an individual footing. So this is an important term while discussing in second midterm the definition form. So why we are not dividing it by F as discussed below? These are some authors are dividing gamma df by F, because in this footing we are using gamma df as full full pressure is being applied by this soil, so why should we divide it by factor of safety? This doesn't make sense, hence this formula of gross safe bearing capacity is allowable. And the next is net safe settlement pressure. That settlement is allowed, that is 25 to 40 mm of a building, of a structure, whatever we have constructed, it is allowed over there. So the next and the last is net allowable bearing pressure or capacity. This is Q and A. The net allowable bearing pressure, what is it? It is the net bearing pressure which can be used for the design of foundations. As the requirements for the design of foundations are that there should be no shearing failure, and moreover the settlement should also be within the limits. Limits are 25 to 40 mm, as we can say net safe settlement pressure. The settlement pressure must not exceed the limit prescribed by Tajagi. And what net allowable bearing pressure over here is QNA is equals to QNS. If then this one is denoted as QNP. If it is greater than QNS, then QNS will be taken, and QNA is equals to QNP if QNP is lesser than QNS. So these terms are some kind of confusing, but we have to remember all these 6 terms in the terms of bearing capacity, what is different from other. So these kind of bearing capacities must be learnt accordingly, numbering the equations like equation number 1, 2, 3, 4, 5, 6, whichever the number you give them, and every equation having sense while considering the numerical values. While considering the numericals will be what we will discuss in the next further videos. So first of all, these terms are important, so you can study them. Next lecture we will study the Rankine's analysis.